right. Greetings to our participants. Welcome to today's session. It's all about exploring industrial engineering. This is day 2 for our participants who are watching this recording. Thank you so much for watching the recording, and for our live participants, thank you so much for joining the session. If you have any questions and answers, please hold them in the chat box, and I'll make sure that your questions are attended to. Without wasting time, I'll hand over to Casper to share the house rules. Over to you, Casper.
Casper?
All right, it seems like we've got some technical issues. So the house rules are basics. Kindly please keep your microphones muted as well as your cameras muted, just to minimize disturbances for the presentation. Without wasting time, I'll hand over to you, Mr. Khabo, and thank you so much once again.
Thank you, Tumelo, and good afternoon to everyone. I'm going to share my screen quickly, then can you all see the screen? Can you see the screen?
Yes.
Oh. Okay, thank you. So let's start slideshow from beginning. Thank you. So today we are going to explore the tools of industrial and systems engineering, which is learning unit number 2 of the MOOC. I'm here with Professor Ramdas. He just joined us now, so we'll be doing the presentation together. So I will present and I will talk and I will talk. So the agenda today, we are looking at systems thinking tools and industrial engineering tools. Systems engineering tools in action. I'm sure you can see the iceberg illusion there on your right, where normally we call it an iceberg, because normally an iceberg you can only see the top there, but the bottom you won't be able to see it because it's hidden. Normally some ships sink because they will dodge the top one, but only to find that maybe this bottom ice is a bit wider, and then it might, accidentally sink because of the collision. So this is a systems engineering tool called the iceberg. So you can see here, we made an example of the top part is what people see. So in this example, people can see success, but they don't know where the success might be emanating from. So what people don't see, probably they don't see that you have already set a goal and you are dedicated towards that goal. They don't see the hard work that you have to put in. They don't see the good habits, for instance, being punctual and timely, and also having room for disappointments, because life, you won't necessarily get what you want. Issues of sacrifice and failure. Failure must not be seen as a negative thing. It's a lesson. So if you do something and you don't succeed, what you need to take from it is how do you learn from that mistake so that you don't repeat the same mistake again. And persistence. People don't see how persistent you are in trying to attain whatever goals that you have. And all they see is the other top part, which is success, but the bottom part is hidden. So the bottom part is very important, because that's where the nuts and bolts of what you do happen. Another one is casual loop diagram, or an CLD, which is another tool of systems engineering or systems thinking. So you can see here, you have an egg here, you have got a chicken here, but we have this thing called reinforcement loop. For instance, as I'm going to try to explain the logic here, as your number of eggs multiply, it means you're going to have more chickens because they will hatch, and more chickens mean there will be more eggs because they lay eggs every day, except for one day in a month. And if the eggs are fertile, they will then turn to chickens or to chicks. But then at the same time, there's a balancing loop. You can see this one is positive, meaning it reinforces, meaning the more chickens, the more eggs, and the more eggs, the more chickens. But then you have another parameter that we've put in there, which is road crossings. So I'm sure you have heard of why did the chicken cross the road? But here, the rationale is if you have more chickens and they are crossing the road, more chickens will probably die from being hit by a car or be snatched and eaten or whatever. So you can see as more chickens cross the road, this is we call it a balancing loop, meaning it balances this one, because as more chickens cross the road, more chickens will die and it will reduce the population. So it's a cycle. So it's another systems engineering tool that one can use. We've just used the chicken and egg because everyone can relate to it. But the same thing can see here, the abstraction is more complex now than a chicken. And here we have potential adopters, we have adopters. So for instance, when you have a new technology will probably, you have potential adopters, meaning it is the population, all of us who might adopt this technology, but not all of us are going to adopt it. But then what happens is that let's start on the right. So as there is word of mouth, be it also advertisement on TV or radio, wherever, or on social media, the number of adopters goes up. As word of mouth or advertising increases, number of adopters will literally go up, but that will reduce the potential adopters, because let's say you have a population of 1 million, and as you have people adopting this particular technology, it will reduce that number from 1 million to, if maybe you have 100,000 people who have adopted the technology, here the number of adopters will reduce from a million to 900 and so it will reduce from 1 million and it will reduce by 100,000. So it will be 900,000. So this side is balancing, this side is reinforcing, because as the adoption rate increases due to the word of mouth or advertising, the number of adopters increases. But as the number of adopters increases, it will reduce the potential adopters from that pool of 1 million, for example, to 900,000 if you have 100,000 people who have adopted. So this is just an application of systems engineering tool, which is a CLD. We call it a casual loop diagram. You want to show the relationship between variables. Okay, so this is, now we're going to talk about industrial engineering tools in action. Those systems engineering tools are not all of them. They are still a couple, but we have just limited those to those other two, which are ones that are normally used, but there are many more others. Oh, here we are. Prof. Ramdas, can you here speak a bit about some of the industrial engineering tools, be it because I think this presentation is not the correct version because I don't see the IE tools here now. But in IE, you have things like your, it can be simulation that you will use as a tool to simulate a scenario before you design. It can be Pareto analysis. It can be an industrial engineering tool. You can use a work study, which is an industrial engineering tool. I think yesterday we went into work study. I think Professor Ramdas spoke to work study based on his experience in the clothing and electronics industry.
Sorry, Kabo.
You can go
You
ahead.
can hear me?
Yes, go
Thank
ahead.
you so much, Kabo. For industrial engineering tools, yes, you mentioned work study is one of the very, very important tools that we use in terms of improving a situation, a problem, or anything in its context that should basically cause problem to a human being or a machine or whatever the case may be. And we spoke a lot about input, process, output yesterday. So if I had to define work study, so work study is a generic term used for those techniques, basically method study and work measurement for the evaluation of human work in any environment. So I spoke about now method study and work measurement. So what is method study? So method study basically looks at
Yeah, you're breaking, Prof.
everything that a person. Can you hear me?
Yes, we can hear you now.
Yeah, no, there was an incoming call, so I had to cut it off. Okay.
Okay.
So a method study basically looks at the method of the method the person used in doing his work. So in a lot of industries, for picking up something, there is a code and there is a time. So normally when we're using method we basically eventually when we analyze that method, we find that in that method we also do a time study. So work measurement means measuring the work. So we use time study as one of the ways in which excuse me, we measure the amount of time a person spends on that particular operation. So we speak about method study and we speak about work measurement. So during the course of the analysis of work measurement, or no, sorry, using work measurement as a tool to basically evaluate the amount of time that the operator is using to do a particular task, it goes in conjunction with the method the person is using. And in addition to that, we also look at the ergonomics, the workplace dynamics, meaning that wherever the person is doing the work, it's a workplace. How is the operator working within that workplace? If you look at yourself sitting and driving a motor vehicle, there is there are I mean, it's simulated in such a way that everything is visible, and it makes life much easier in order for you to maneuver that vehicle on the road. In the same way, the term is called ergonomics. So ergonomics basically looks at man machine interface and how that interface takes place. So work study basically means the study of the work that is involved in a working environment, analyzing it and finding better means and better ways of doing it, and basically eventually setting a standard time in order to do that particular job. So when one sets a standard time, let's say for example, the operator takes 1 minute to do that specific job. So the operator is supposed to produce 60 units in an hour, because his standard time is 1 minute. Okay, so that's basically how work study works. Thank you so much, Kabo.
Thank you, Prof.
Right.
For that. I wanted to share a quick video on what you just explained now.
So, Kabo, I'm going to be driving now from the hospital to back home. So I will be listening to you. Yeah.
I think Caspar showed me yesterday. You need to unshare first, so that they can be.
Kabo, so I'm driving now. Yeah, from hospital
voice,
to back home.
You can't hear anything.
Kabo,
so
can you hear me?
Redo it. Share.
We can hear you, Prof.
Computer.
All right. Thank you so much.
Win at work by communicating effectively with Grammarly.
Meet Ty. He is emailing a difficult client.
I think we should explore a few
Can you
solutions.
hear
Grammarly
the
ensures Ty's confidence comes through in his writing. That way, clients see him as professional and polished every time.
Let's explore a few solutions.
And the objective of
Meet
industrial
Dylan, who's
engineering,
prepping for a big
responsibilities,
investor
and
presentation.
techniques
The
used
revenue
in
that our
industrial
business
engineering.
will
And then few
generate
examples of
will
industrial engineering.
triple in the next year.
So let's start about.
Grammarly helps Dylan rewrite his point to be clear and compelling.
Our business's revenue will triple in the next year.
That's the reaction we want. And then there's Anya, who's drafting a global IT proposal. When unnecessary phrases
The topic
slow
what is
down her
industrial
writing.
engineering. It is a system by which we develop
Grammarly helps her
manufacturing
be
system
concise,
efficiently
so her
and
point
effectively.
makes an impact.
It means like when we will improve our manufacturing
92% of
system
professionals who use Grammarly
to
say it's helped save
utilize
them
it
time.
properly and
What makes Grammarly such an
efficiently and
intelligent writing
effectively,
tool is that it's
it
powered
is
by
an
billions of
industrial
user
engineering.
interactions.
So industrial
Go to
engineering doesn't
Grammarly.com.
work for
Right there.
to produce the parts. Like it is not a production engineer. It is an industrial engineer who is work for improvement or work to make things better by their processes, tools or systems. I'm Raman Pahuja. Today we will discuss the main tools of industrial engineering, like we can say the lean manufacturing. So we will discuss about the introduction. On the next training we will discuss about the lean manufacturing of industrial engineering, responsibility. We will talk about the objective of industrial engineering, and then a few examples of anybody is talking about the objective. Let's start or goal about the topic. Then we should remember that our goal is a system by which we develop manufacturing system efficient.
Mr. Khabo,
Tumela?
you were opening two tabs, so the sound was coming from another tab there.
Oh, there are two tabs here.
I meant on that video, you first opened the first one, and then it was playing, and then you opened another one. So we're hearing two sounds, and it was a bit confusing.
Oh, now let me redo it.
All right.
I don't know what happened there.
Hello friends.
Is it fine?
I'm Raman Pahuja.
Yes,
today we
well,
will discuss about the industrial engineering.
Maximize it. Thank you.
So today we will discuss about the introduction and the objective of industrial engineering, responsibilities and techniques used in industrial engineering, and then a few examples of industrial engineering. So let's start about the topic what is industrial engineering. It is a system by which we develop manufacturing system efficiently and effectively. It means like when we will improve our manufacturing system to utilize it properly and efficiently and effectively, it is then industrial engineering. So industrial engineering doesn't work for to produce the parts. Like it is not a production engineer. It is an industrial engineer who is work for improvement or work to make things better by their processes, tools or systems. Like the main tools of industrial engineering, like we can say the lean manufacturing. So we will later on the next training we will discuss about the lean manufacturing. So then we will talk about the objective of industrial engineer. anybody is talking about the objective or goal, then we should remember that our goal should be SMART. SMART means S for specific, M for measurable, A for achievable, R for retainable, and T for time bound. So everybody should know, like, our goal should be SMART. So if industrial engineering work for an objective, then its goal should be SMART. Okay, so objective of industrial engineer is mainly figure out the ways to do things better, and then they work as a process improver. They are not work as a production engineer, or they are not work as a quality engineer. They work as a process improver. Like, they will improve the process by any other way, like by Kaizen, by Pokayoke, by lean manufacturing tools. Like, so they are work as a process improver. Or the next objective of industrial engineer is to do the continual improvement in the plant. It is continual, not continuous. Okay, so responsibility of industrial engineer is project management. The major responsibility is project management, because if we are doing any improvement, or if we are doing any change in any process or anything, so we should work as a project. If we are not taking as a project, then we could not do this properly. So first thing, the responsibility of industrial engineer is project management. So he has to manage the project, like he has to time bound the project, and he has to make a goal of that, like what we should do, and the goal should be SMART. So next responsibility is time studies. So if we want to do the any improvement in process, to reduce the cycle time, to increase the productivity, so we should do the time study first, and then bottleneck analysis and eliminate the bottleneck analysis. Do you know about the bottleneck? If, like, if we are doing, if I will draw a bottle, so you can see this is the neck of a bottle. Okay, so if we will cut the bottle from here, so it will be easy to pour a milk or water in the bottle, and it will be easy to remove. But if we will talk about the bottleneck, then it will be difficult, because it is a congested space. So same as in the industrial engineering also, bottleneck, it is the meaning, like where our process will take maximum time, so it is the bottleneck. Like, for example, we will say process A, process B, and process C. So if it will take, process A is taking 6 seconds, process B is taking 5 seconds, and process C is taking 8 seconds. So it means process C is a bottleneck analysis. Bottleneck. Okay, so it is our analysis that the process C is bottleneck. So we have to eliminate it, or we have to balance it, like this, or like process B and process C should be merged, or something we need to do to balance this properly. Okay, so it is the bottleneck analysis and eliminate the bottleneck. So we will discuss about the proper description in the next training. Okay, and the other responsibility of industrial engineer is improve plant layout, because if we will do the time study and if we will do the layout improvement, so that is also a responsibility of industrial engineer. Okay, the next responsibility is develop lean manufacturing system. It is the main thing, because in lean manufacturing we will get all the tools like Kaizen, Pokayoke, 5S, Andon, labeling production, and all, etc. It's the 25 tools of lean manufacturing. So about lean manufacturing, it will be our next training. Okay, so this is our responsibilities of industrial engineer. Then we will talk about the techniques used in industrial engineering. So first technique, like, for I already discussed, like time study. If we need to do the time studies, or we need to do the cycle time reduction, so we have to do the time study. And then muda elimination. Muda means wastage. Okay, muda is a Japanese word, it means wastage. So we have total 9 waste. Earlier it was 7 waste, everybody knows the 7 or 8 waste, but now it becomes 9 wastage. Okay, so we will discuss it these wastes in also in next training. Then the next tool is Kaizen. Kaizen means continual improvement. Like everybody can see, it is not continuous improvement, it is continual improvement. Continuous means like if we are doing something like this continuously, so it is wrong, because if we will do continual, then we are just sustaining anything. Like here we will sustain, here we will sustain, here we will sustain. So if we are doing any improvement, so we have to sustain it firstly, otherwise there is no any benefit of our improvement. Okay, so that is the continual improvement. Then the bottleneck analysis, as I earlier told, and then the root cause analysis. Root cause means if you are having any problem, having any defects or any issue in the process, so we have to do the root cause analysis. Root cause analysis is, there is a lot of methods like 5Y, or we can say YY analysis, then DMAIC, 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 and other roles like 8D, 8 discipline. Okay, so these we will discuss. These are also the tool of lean manufacturing. Like root cause analysis is a tool of lean manufacturing. So we will discuss in our next training. Then we will talk about the standardized work. Okay. So here is some examples of industrial engineering, or we can say improvement. Like earlier assembly line of Ford, this is the manual assembly line. You can easily say like there is a lot of mans in the line and the manually they are assembling the car. And then modern car assembly line in Volkswagen, like here you can say only one member is here, one person is here, other all area is free. Only this is automatic assembly line. So this is just because of industrial engineering, because they have done some improvements in that, they have done the automation in the assembly line. That's why we can do like this. Okay, the example 2, it is not an like industrial engineering, but it is it we can say like Kaizen, like small improvements are also important. So like you can say forget to turn the air conditioner off. Okay, so if you cannot see, like in the earlier type of ACs, we cannot see it's off or on, so we cannot confirm with the eyes. That's why they have some attached the ribbons to the air outlet, like you can see. So with this we can confirm easily with the eyes, like our air conditioner is on or off. Okay, so these were the examples, and thanks a lot for watching this. And if you have any question,
thank you for listening. A short presentation on the tools and techniques of industrial engineering, and I think Prof spoke in detail to time studies, which are one of the most important techniques that any industrial engineer has to use in a factory, so that you can optimize flow and improve speed, throughput, quality, safety through time studies. Prof, any other words from you from that video? And I think the one technique that is very important nowadays is the technique of lean manufacturing, because you want to reduce waste and non-value adding activities in your production line or in your service line, be it in a bank. In a bank, they will use queuing theory, where you know that you have a variation of people that come. They don't come to the bank at a predefined rate. They will come anytime and drop in. So you need to have a queuing system that is able to, have enough capacity to take into consideration those variations, whether there is high. We all know from history that maybe just between 12 and 1:30 people go on lunch, and in the olden days, nowadays people don't even go into the banks. But in the olden days, when people go to the bank, it will be during that period. You will need to stagger your shift so that your tellers do not go to lunch at the same time, and make sure that you have enough capacity to deal with that peak during at lunchtime. And then immediately after lunchtime, then people can start going maybe at about 2:30 or 2 o'clock, because the queue will have lessened and the capacity will be higher. Then you can release resources to go to a lunch, for instance, or someone knocking off at 3, things like that. And the same thing in industrial engineering, you can apply it anywhere, whether it is in a production factory like that video where you do motor assembly, but even in a hospital, because you have people coming in. How do you improve the flow of people from the time they open up the hospital at 7 or whatever, when people go and fetch their files, to the time they see a doctor? You'll find that you want to reduce as much as possible the waiting time, because waiting is waste. People could be doing something better. It's one of the 7 wastes, waiting, of lean manufacturing. So you need to find a way where you can try to optimize the flow, so that you've got a good flow of people going through the system, from triage to seeing the doctor, to going to the pharmacy to collect medicine, to being booked in for you need to go to the wards or whatever. So industrial engineers are able to work anywhere, where as long as there are systems, processes, and people, an industrial engineer can work there. Prof. Ramdas?
Thank you so much, Cabo. So I just wanted to add to the conversation that everything in industrial engineering is about continuous improvement. CI, normally called CI, and also called Kaizen. If you look at the Japanese always follow the Kaizen rule, and also look at the Toyota production. They have basically formulated Toyota production, which is basically continuous improvement. So I clicked on the video as well, where the gentleman spoke about DMAC, but he didn't tell you what DMAC was. So DMAC is part of Six Sigma, and it basically stands for define, measure, analyze, improve, and control. So it is basically a methodology or a tool on its own used to evaluate situation. In future, it's all about processes. I spoke to you yesterday about your body. There are processes that goes through in your body so that you are able to do what you do. So also in a working environment, there's a process as well. So industrial engineering focuses on the process to ensure that the process is optimized, so that the process is giving us maximum output, in terms of what we want and what we can achieve. So we mustn't be in a situation where we run. I mean, that a motor vehicle, the speed limit is 200, but do you drive it 200 all the time? No, because you'll either get a speed trip or you'll basically crash the vehicle. So we try to optimize to say, okay, 120 is the maximum speed we can go, so that we consider health and safety of the motor vehicle, health and safety of the driver, and so forth and so forth. So these are very, very important aspects that one has to look for. Yes, we can optimize, but we must do it in a sensible manner, so that if you, as I said, if you drive the vehicle at 200 kilometers per hour, it's only going to last you a day or two. So we don't want it to last, and then we're going to repair it. And we do not want to be repairing it all the time, because it's costly. It costs money for us to repair, and there's time wastage. And also it can disrupt the entire line of production when we are doing this. So also mentioned in work study. So work study, it looks at defining the problem, define, measure, define, is one of the most important things that we look at. We always speak about a problem in industrial engineering. So if you have not defined the problem well, you are not able to solve the problem well. So it always goes back to to you as a sensible industrial engineer, applying yourself accordingly so that you are able to optimize the situation. I mean, if you look at your home, your kitchen is designed in a certain way that makes it easy for whoever is preparing to basically access all the utensils, all the resources in an efficient way. And also, you need to think about next time you make a cup of tea, there's a process involved. I mean, there are certain things that can be done simultaneously and certain things that need you to follow a procedure. So there is always a way in which to do things. So it's important that you bear that in mind. And that is the way industrial engineering operates so that it can achieve its desired result in terms of optimizing and improving the current situation. Thank you so much, Kabo.
Thank you, Prof. And I think the other important tool is economics, because which is how it has to do with safety. When you design processes, you want to design a process or a system that is safe for employees. For instance, industrial engineers also will design sitting postures in factories so that you will study how employees are probably sitting when they work, for instance, and the effect of maybe they are not sitting up straight, and it will probably start affecting their spine and is sore and things like that. So an industrial engineer also plays a role in economics to ensure that you design systems and processes that are safe for employees and do not cause occupational hazards to the employees. So that is just another application that one has not yet mentioned. And I think yesterday we spoke about productivity measurement. I think Prof took a lot of time in terms of showing how you even calculate productivity, which is a ratio of input to output. What do you put in and what do you get out? So if you put 10 Rand and you get 5 Rand, then your system is not optimal, is actually running at a loss. But if you put 10 Rand and you actually get 15 Rand out, then there is good return on investment. So efficiency is up. So those are some of the things that industrial engineers do, and techniques that they do, and also economics, which is engineering economics. To produce a particular part, you need economies of scale. For instance, an industrial engineer has to be able to calculate those economies of scale, things like your net present value, so economics also plays an important role in industrial engineering. What is the break-even point when we produce? And if we produce below X amount of units per hour, then we are running at a loss. We need to produce X amount to break even, but to make a profit, we need to produce another Y amount. So those are the things that tools that industrial engineers also deploy so that they can improve efficiencies, because at the end of the day, you want efficiencies. And you want process efficiency, system efficiency, product efficiency, and issues of safety becomes very key, because safety is one non-negotiable parameter in industrial engineering. You want to run safe systems in the plant, be it in the plant, be it in hospital or wherever. And industrial engineers also, play a lot of a role in terms of design of material handling equipment. For instance, what type of equipment do we need? They design jigs and fixtures, so they will use their knowledge of design, which is a tool. Then they can use CAD, for instance, to design a fixture, and then once the design is finalized, then they can get the mechanical engineer to actually do the actual part and be able to test it and see that it passes all the required safety standards. And that is briefly some of those things. So issues of production planning and control. How do you plan and control production in a plant? How do you plan and control a service in a hospital? That is forms part of the ambient influence of an industrial engineer. They also use operations research as another technique. And operations research, you are either maximizing profit or maximizing efficiency and minimizing. You only have two things that you can do with operations research. It's either you maximize or you minimize. So you minimize the cost and maximize the profit, or minimize the waste and maximize the efficiency. So you can use operations research to do that, which is more of a mathematical approach towards analysis. I think we have covered most of the tools that industrial engineers do use. I'm not sure if we can give now opportunity for questions and answers. And another tool, before I forget, is quality engineering. All the things that you do, be it in production or be it in service, you want your quality to be optimal so that you are giving your client value for money. So what they pay, value is function over cost. So whatever you are offering over the cost that they are paying, do they derive value out of it? So yeah, and as you saw in the video, mainly the work of an industrial engineer is improvement. So you need to improve processes and systems that are installed, and you also install new things or new approaches, but you are not going to leave them at that. You are going to install them, but you're going to improve them with time so that you continually grow. Okay, so I think that was it. Maybe we can give now an opportunity for questions and comments. I see Tumelo, you can go ahead.
I'm just opening the floor to the participants. If anyone's got a question, feel free to raise your hand or to send it on the chat box, and Mr. Havo will certainly answer your questions. Thank you.
Mr. Tumelo.
Yes, Mr. Havo.
It looks like we don't have questions here, but I want to find out, the presentations, we had one yesterday, should we, do you have them, or should we send them to you just for your records?
Oh, it will be great for us to receive the presentations. Thank you.
Okay.
And then as for online participants, if you want to see the recordings will be available on our MOOC website. And if you have any questions, perhaps later on, for those who are watching the recording, please don't hesitate to email us, and we'll certainly get back to you. Thank you.
Okay, no, thank you. I've shared our email, my email, and that one of Prof. Ramdas. If later there are participants who want to send questions, they can send them to Tumelo and copy us, and we will make sure that we respond to those questions.
All right. Thank you so much, Mr. Howard. I see we still don't have any questions. For those of you who still have any questions, feel free to unmute yourself or raise your hand. Your questions will be answered. But I see we don't have any questions for now. Mr. Habo,
if you can also just share the link and the process of the MOOC for those who are joining for the first time.
Do we have anyone here who is not part of the MOOC? Millicent, Mohale, and Tabelo? Are you part of the MOOC?
Yes, I've just joined like a while ago. It's my first time here, so I'd appreciate the links.
And then what about yourself, Millicent and Mohale? All right. If you have any questions regarding today's session, kindly please email us. Our email addresses are on the chat box, and we'll certainly get back to you. Otherwise, I'd like to thank you, Mr. Khabo, if there's anything that you'd like to say.
No, I think we are covered with Prof. Ramdas. We will make available the presentation and make sure that it is on your MOOC site, and colleagues, whoever wants to see it can be able to do so. Thank you.
Sorry, colleagues, Kabo, if I may come in.
Yes.
Thank you so much, Kabo. I would also like to hear the voices of the students we are speaking to. Yeah, maybe 2 or 3, questions from the students where we are able to explain certain things. I would really appreciate that. Thank you so much. 1 or 2 students can please, put your hands up and speak so that we can hear. Are you learning something? How can we improve and so forth? So I would like to hear your voices as well. Thank you.
Thank you, Prof, for that. Anyone who wants to say something for a few seconds and reflect on what was presented today or yesterday? No, I think the students are shy today, so it's okay. I think there's someone who wants to say something. Is it Mungala? Go ahead.
Yes.
Go ahead, Mungala.
Afternoon, everyone.
Afternoon.
Yes, I think we have shared a lot. We have gained a lot from yesterday's presentations when we were dealing with industrial engineering systems. I think we have shared a lot, and then it's for us maybe to follow you in order to map our way as far as this curriculum atmosphere is unfolding nowadays. Thank you.
Thank you, Mongala. Prof, you heard what Mongala said. Did you?
I was cut off for some reason. Please, if you can repeat what he said. Thank you.
Yeah, okay. Mongala, would you give us the honors and maybe just for a second again repeat? I think Prof was cut off for a second there. He couldn't hear you.
Okay.
Thank you. Go ahead.
Prof, I was saying, since from yesterday's presentation regarding this industrial engineering systems, we've gained a lot from what you presented with your colleagues over that side. And then I've further said it is up to us maybe to follow on this virtual workshop in order to map our way forward, because the curriculum is unfolding now and there is no age limit for us to say, I can't do this, I can't do this. Ours is just to follow. So keep on sharing with us in order to understand what's happening around. Thank you.
Thank you, Mongala. So you had that, Prof?
Yes, thank you so much.
Okay. No, thank you. So yeah, maybe we will pause here, and then we will meet again tomorrow for learning unit number 3. Same link, same time at 3. Tumelo, to you, you can maybe close the meeting for us, sir. Go ahead.
All right. Thank you so much, Mr. Howen. Thank you so much, Prof. To our online participants, thank you so much for your engagement. For our guests who are watching the recording, thank you also for taking the time to watch the recordings. If you have any questions regarding today's session, please don't hesitate to email us. And then otherwise, I'll close the session for today and see you tomorrow at 3 o'clock. Thank you so much and have a lovely Tuesday.
Thank you. And